Now we are inside the celestial coordinate system, CRF, and I have explained that with some transformations from the local local acceleration, you can come to coordinate in CR. But we know that the satellite acceleration is not only due to the Earth's gravitational field. There are other forces acting on the other type of accelerations, which are divided into groups of gravitational and non-gravitational. So, as you see, the acceleration that a satellite has is not only from the gravity field. Other fields, other things also affect. Now we are going to discuss which type of forces the acting on satellite. Why is it important? If you want to use the satellite acceleration to determine the potential or spherical harmonics of the gravity field, which is here, you need to remove the non-gravitational and non-gravitational acceleration from the observed acceleration of the satellite. That's the principle which is applied for gravity field modeling using from the orbit only. So what are these accelerations? Gravitational acceleration or gravitational perturbation. The first one is called third body effect. Which third body effect is the effect of other planets, and one other is general relativity, if I'm not mistaken. Yeah. Third body effect is direct and indirect. So now I explain what is it. Indirect is called solid tide, ocean tide. Is indirect effect. So let me draw a figure. If I have the Earth here and I have one satellite here moving around the Earth, I have moon here and I have sun here. The gravitational attraction of the sun and moon will influence the satellite movement. They pull the satellite toward themselves. And consider that moon is moving around the Earth, and Earth and moon together moves around the sun. See that these directions are not constant in space. They are moving in different directions. And we need to consider this perturbing force, these perturbing forces. And this is called the direct effect. The other planets Here I say sun and moon. The other planet drag the satellite, pull the satellite towards themselves, and they deviate the satellite from its own orbit. And the indirect effect is that this gravity, the moon and sun, changes the gravitation of the earth. And when the gravity changes inside the earth, then the satellite movement is seen. Because the satellite is very much affected by the gravity of the earth. And if the sun and moon change the gravitational field of the earth, they indirectly change the deviate or drive the satellite out of its trajectory. So we have indirect effect. Probably you know that the indirect effect or the tide, we say we have solid tide and ocean tide. Ocean. What is the difference? So we all know that the Earth has three layers: lithosphere, mantle, and core. And the mantle part, which is the middle part actually, is viscous. Let me draw a figure for you. If this is the Earth, here we have lithosphere. Here we have core, and here mantle. Mantle is viscous, is soft. When any force from the sun or from the moon, I say moon here, drag this toward them. The crust or the lithosphere is pulled upward a little bit based on, because the central part, the mantle is viscous. So this means that when the Earth is rotating, when we have the Earth here and Moon is here, this side of the Earth, which is under the Moon directly, goes up, and also the other side, because if it doesn't do that, then the balance of the Earth and the Moon system will change. So if we have tide here, we will have high tide there as well to keep this. So it means that the Earth's crust is going up and down every day, and it is about 50 centimeters, 54, I think. So this 54 centimeters occurs in all the Earth. It's not only one place that's cosmos. So the whole plate, the Earth crust or the atmosphere goes up and down every day, because when the Earth is rotating, this part of the Earth goes down and the other one goes up, like this. So if we have these sectors like this, here we have always positive, here they will go up, and after that they go down. It's like that. So if Moon is somewhere here, this part of the Earth, every place which is under the Moon goes up, and when the Earth rotates, this goes down, the next place goes up. So they also say that the Earth is breathing. This is called solid tide. The situation for the ocean is very similar, but the ocean, the issue is that it's water. Water is moving fast. The water is a fluid. It's not it goes from one side to another side, and when the they go to another side, they get heavier. That part will be heavier, and they change the gravitational field of the Earth. And when this movement, this Earth rotates, the water goes to another side, and that part will be heavier. And so a little bit different, but the principle is that the Earth, the moon can change, moon and sun can change the gravitational field of the Earth. It can cause that the shape of the Earth change a little bit. The lithosphere goes up and down, and this also affect the gravity field of the Earth. And also water from one side move to another side. That's also change the gravity field of the Earth. That's called indirect effect. So how to model this effect? Simple. There is a formula. Simple formula for considering that for the direct effect. The direct effect, you can simply use this. Let me see if I can find a good formula for you somewhere. So this is the acceleration that you have. And this acceleration equals that. It depends how many masses do you have. So if you have the first masses, for example, moon, you will write like that. Delta 1 over delta 1, 3. But this delta is a vector minus r 1, 3. This one is vector. For example, if m is the mass of the moon, and this is the distance between the moon and the satellite. It's called the position vector of satellite from moon. There's the position vector from the Earth. So this one is a vector, and this is the absolute value of the vector, or the size of the vector. For sun, simply I write 2. And if you want to consider sun and moon together, simply take the summation. This is summation. Then this will be, for the sun, is a satellite position with respect to the sun, and the satellite position with respect to the Earth. That's all. You can compute the satellite acceleration with respect to the moon and the Earth by this formula. That's called direct effect. However, indirect effect is not that simple. It's not that simple. Then we have to look at some other parameters. Let me explain this in another way.